And we are back with the notes, ladies and gentlemen. We're going to be talking about end behavior. Now, ladies and gentlemen, math people are not creative. We are not known for it. So if we're talking about end behavior, we're asking what happens at the end. Now you say, well, yeah, duh. The problem is, y'all don't get it. On a regular basis, you just don't. I don't know why. That's the way it goes. Let's talk about the graph of x squared. In this case, I would hope that everybody would agree that as x goes towards positive infinity, moving this way, that y, the graph, is going up. That means that y goes to positive infinity. So as x goes positive infinity, y goes positive infinity. Just like every point we ever write, we have an x part and a y part. End behavior always has to be written in two pieces. As x goes to positive infinity, comma, y also goes to positive infinity. Now, let's go do the hard one. Let's go to the opposite side. As x goes to negative infinity, that means it's going this way because it's moving from 0 going to negative infinity. Some people say, why don't we write negative infinity this way with the x as x goes to negative infinity? But then you would be reading backwards, so we don't do that. So let's go as x goes to negative infinity. Where does y seem to be going? As I go back, it seems to be going up, up, up again. So that means as x goes this way, y seems to be going up. Y goes to positive infinity. So again, we're going to write it. As x goes to negative infinity, that way, y goes to positive infinity. Just like a point. Okay, now that we have that out of the way, let's try another one. In this case, people like this one. As x goes to positive infinity, as it goes this way, y goes what way, people? Up. Positive infinity. Now, as x goes to negative infinity this way, y seems to be going, down to negative infinity. So again, over here we would write end behavior. As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. That's the answer to end behavior. Now, here's the one that Abe Lincoln's everybody. Here we go. In this case, I have a graph that comes here, does this, it turns around and up and down and around and through, and then goes down. In this case, I want the end behavior. The answer is, I don't care what happens in the middle. So, I'm covering it up. I don't care what happens. As x goes to positive infinity, you say, how's it going to positive infinity? It's going down. It's x. It's moving this way. What is the graph doing? As x goes that way, y goes down. So we would say as x goes to positive infinity, comma, y goes to negative infinity. Over here, as x goes toward negative infinity, it seems to be going, as far as I can see, down. So y therefore goes to negative infinity. I don't care what's happening in the middle because this whole section is called end behavior. End behavior. Only what happens at the end do I care. All right. Now, there's one more that is total JFK. Here we go. We have this. Now, the challenge here is, again, I don't care what's in the middle. What I want to know is as x goes to positive infinity, where does y seem to be going? It does not seem to be going up. It does not seem to be going down. It seems to be leveling off somewhere near, let's go with 0. So as x goes to positive infinity, y goes toward, not up, not down, 0. Now, as x goes to negative infinity, goes this way. Now, it doesn't have to go to 0. Let's say it levels off fairly high. We're certainly not going to say that y goes up. We're certainly not going to say y goes down. We're going to have to say y levels off somewhere, and it may level off at some number. Just for random, I'm going to say y seems to be approaching positive 2. So I would say as x goes to negative infinity, y goes to 2. Now, having done almost 7 minutes of video, I'm going to come to class, and you all are going to be confused because you're going to make it way, way, way too hard. All right.